Hi everyone, this is Ahmed Bilal. I'm solving question number 22.50, which says a positive point charge capital Q is located at x is equal to a and a negative point charge negative q is located at x is equal to negative a. A positive charge small q can be placed anywhere on y-axis. Find an expression for F net x, the x component of net force on small q. So according to the question, our figure will look like this. Here we have our figure. So this is our charge of interest small q. This is our charge negative q. So these guys will attract and the force F2 would be in this direction. And since both of these charges are positive, so these guys will repel and this would be the direction of force exerted by capital Q on small q. Okay, R2 is the distance between negative q and small q, and R1 is the distance between capital Q and small q. So let's get started. So according to Coulomb's law, F1 is equal to K, capital Q, small q, or R1 squared. So the x component of F1 would be F1x is equal to negative of F1 cos of theta. And we can put the value of F1 into this equation and cos of theta, which from our figure is A over R1. And we'll get negative A capital K capital Q small q over R1 cubed. So here we can find out R1 from our figure. Let's have a look back at our figure. Okay, here's our figure. So R1 is the distance between small q and capital Q. So we know these two sides of the triangle. So we know if we have to find the third side of the triangle and we know two sides, we can use Pythagorean theorem. So here's our Pythagorean theorem, which says hypotenuse square is equal to perpendicular square plus base square. And in this case, R1 squared is equal to y squared plus a squared. And taking square root on both sides gives us R1 is equal to square root of y squared plus a squared. We'll put this value in our equation. Let's get back. Alright, so using Pythagorean theorem, we'll get F1x is equal to negative of a k capital Q small q over y squared plus a squared square rooted and cubed. Okay, so now we have our F1x and we need F2 and we need F2x. So in order to find F2x, we need to find F2 first. So the F2 would be very similar. We'll find F2 similar to F1 because they both use Coulomb's law. And with the help of Coulomb's law, we'll get K, the product of those two charges, capital Q small q over R2 squared. Alright, so x component of F2 would be negative of F2 cos of theta, just like we found for F1x. So we are putting our values. F2x is equal to negative k capital Q small q over R2 squared multiplied by a over R2, and we get negative k capital Q small q a over R2 cubed. And just as we found R1 from the figure, we can easily find R2. Let's have a look back at the figure. So here we have our figure, and R2 is the distance between negative q and small q. And we can, as we discussed earlier, we can find this side of the triangle by using these two sides according to the Pythagorean theorem. So let's cut to the chase, and we'll have R2 equal to square root of y squared plus a squared. Let's get back to our math work. Okay, so putting the value of R2 in this equation, we get F2 is x is equal to negative k capital Q small q a over y squared plus a squared cubed. So now we know the value of F2x and we also know the value of F1x. We can put those values in this equation and we can find our F net x. So putting the values of F1x and F2x in the F net x equation, we get this guy. Here we have our F1x and here we have our F2x. So when we add these up, since these are both alike and both have a negative sign, so they will be summed, and we'll get negative 2k capital Q small a over square root of y squared plus a squared cubed. And this would be our equation, and we can find f net x using this equation. All right, thank you everyone for hanging along with me. Have a very great day. Thank you.